Now we're going to use u substitution to find the integral of this function inside a function. Notice we have a function, sine of something, but then we also have inside of sine, we have a function also, which is 5x. So what we need to do is called substitution. We need to let u equal this inside function. So u equals 5x, which means the derivative of u equals 5 dx, because I took the derivative of both sides. Okay? See what I did there? Okay?
Yeah.
So then we want, some teachers do it, different teachers do this different ways, but notice what we're going to do is we're going to rewrite this equation. We're going to write this as the sine of u, and we want to write it with the du, so that I can take the integral of sine u du, right? But in order to write this with the du here, we have to substitute dx. So we're going to rewrite dx in terms, we're going to rewrite dx, we're going to solve this equation for dx. In other words, divide both sides by 5. See how I did that? So then dx is actually du times 1/5. So in order for me to put this here, I really can't just put that there. I have to put it like over 5, because dx is du over 5. And now I can take this over 5, which is really like 1/5, right? And I can bring that out in front of the integral. Remember, when you have a constant, you can bring it out in front of the integral. So I rewrote this entire integral in terms of, up here it's written in terms of x. I want to rewrite it in terms of u. The reason I want to do that, you might be like, why did I do that? Why did I go through all that trouble? Because you don't, there's no way for you to take this integral. You don't know a rule for taking an integral of something if you have two different variables here. This is dx and this is not just x. This is 5x inside here. But now I can take the integral. What's the integral? What's the integral of sine u with respect to u?
Cosine 5x.
No, but just cosine u, right?
Yeah.
Don't jump ahead. It's 1/5 cosine u, or is it negative cosine u?
Cosine.
Sure?
Yeah, you only get negatives if you take the derivative.
So yeah, it actually is going to be negative. It's the negative 1/5 of the cosine of u. But now we're going to plug u. What was u again?
5x.
U is 5x. So now we reinsert 5x into there. And there's your answer. Plus c, that's right. Plus c, because this is an indefinite integral. You got to account for a potential constant that you could have had there. And if you're not sure if you did it right, let's check it. Let's check our work by doing the integral. We're going to do, or the derivative. Let's take the derivative of this. If I told you that y equaled negative 1/5 cosine of 5x, what property do you do to find the derivative? What's dy dx? It's called the chain rule, right?
Yeah.
The chain rule says that I take the derivative of this thing, leaving that unchanged. So the derivative of that is 1/5 times negative sine of 5x, and then you multiply it by what?
5.
By the derivative of the inside, which is 5. And when I do that, what's going to happen to the 5 and the 1/5 and the negative and the negative?
They cancel.
The negatives are going to be compositive, the 5s are going to cancel with the 1/5, and so your answer is just going to be the sine of 5x, which is what my original problem was.